All right, in this lesson we'll be talking about percentile scores and the normal curve. The percentile score for any given x can be determined using the normal curve. Likewise, the raw score for any percentile score can be determined. Now, I've written kind of a rule there that you need to, I would say, memorize. What you'll notice for the rule is that I have a given column, then irregardless of what you're given, you're going to always transform what you're given into a z, and then you're going to use that z to find what you're looking for, hence the question mark. So let's look at that rule. If you're given a percentile score, what you're going to do is use that percentile score, transform it to a z-score, and then use that z-score to find a raw score. Likewise, if you're given a raw score, you can use that raw score, change it to a z-score, and then use the z-score and transform that to a percentile score. So a couple of things that I'll mention that you need to be particularly careful about. Make sure that when you're transforming scores from percentile to z or raw to z, if you're on the left-hand side of the distribution, make sure that your z's are negative. That's probably the biggest mistake that students make. The second thing that I want to talk about is how to interpret a percentile. Remember, a percentile score is always at a raw score and below. So for example, if we're talking about the 65th percentile and the raw score there is a 16, what that means is 65% of the scores are 16 and below. And what that means is we get into the problems, you'll see this, and without even really talking about the first problem, but notice in this first problem I've marked a spot, and notice that the thing that's shaded is always that to the left, okay, because that's how you interpret a percentile score. You're at a particular raw score and below. In this second problem, here's where we are looking at, and we're going to always shade to the left. Okay, so kind of keep that in mind as we go. And then another thing of caution is just make sure that you're reading the correct column in the z distribution table. So remember, column A gives you a particular z-score, and it can be positive or negative. Column B gives you the area between the mean and that z, and then column C tells you the area beyond that z-score. So you just got to be careful in how you read the table. And then I guess the last thing I'll say before we get started into the problems is I do again find it very helpful to draw the normal curve and label it, and I think it helps students to actually label it in the same order regardless of what you're given and regardless of what it is that you're looking for. So I always put the raw scores on the top line, z-scores in the middle, and p or percentile scores at the bottom. Okay, so let's look at question number one. Question number one, you're given that x bar is equal to 60, the standard deviation is 7. So the question that is being asked is what raw score marks the 70th percentile. Okay, so I'm going to give you a few seconds to think about it, but are we using the top line of the rule or the bottom line of the rule? So you've got to stop and think, what am I given and what is it that I'm looking for? All right, and what you're looking for is a raw score. So we're going to be using the top line of the table. All right, so what I've done for you is marked our raw score, mean, and we're looking for the raw score that's at the 70th percentile. We know our z in the middle is always going to be 0, p in the middle is always going to be 50, and again I kind of mark that because it helps you maybe remember where is the 70th percentile. And we know the 70th percentile is over on the right-hand side of the mean because it's above the mean. And again, why did I shade here and to the left? Because that's how you interpret a percentile score. Now to get, or to help you understand why that is the 70th percentile, remember on the left-hand side of the curve is 50% of the scores. So to get up to the 70th percentile, I've got to find a z-score that is associated with 20% of the scores. So what you're going to do is go into the table, Appendix A, and you're going to go into the B column, B as in boy, and you're going to find the Z that is as close as possible to 20%. And again, I want you to find the one that literally is as close as possible to it. So one might be 17 units away and one might be 13 units away, and we're going to use the one that's 13 units away. So in this instance, the Z associated with 20% of the scores, and again, you're looking in column B, is the Z of 0.53. So you're going to set your Z formula up so that 0.53 is equal to x. X is our unknown. It's what we're looking for. So 0.53 is equal to x minus 60 divided by 7. And again, take the 7 across by multiplying. So 3.71 is equal to x minus 60. And then add 60 to the other side. So x is equal to 63.71. And again, what I would say is think about, does that make sense? If my x bar is 60, so 60 is right in the middle, and I'm talking about a score that's at the 70th percentile, 63.11 does make sense. Okay? Let's talk about question 2. Given the same mean, same standard deviation, what raw score marks P25, or the 25th percentile? And as it turns out here, we're going to use that same rule because we're looking for a raw score. We're given a percentile score. And so I'm going to give you a moment to stop and think about what is it exactly that you're going to do. What you're going to do is go in and find, I would say still stay in column C and find the Z that is associated with 25% of the scores being beyond that Z, so toward the tails of that Z, or between that Z and the tails. All right, and what I found was that the Z closest to 25%, according to the table, was 0.67. But the thing I've got to remember is I'm on the left-hand side, so that's going to be a negative Z. So minus 0.67 is equal to x minus 60. X is my unknown, divided by 60. Multiply the 7 by each side by 7 to get rid of the 7. So minus 4.69 is equal to x minus 60. And then take the 60 to the other side, and so x equals 55.31. And again, if you think about the 60 being in the middle, it makes sense that something like 55.31 would be at the 25th percentile. Take a moment and see if you can interpret what that means. So how do you interpret the 25th percentile? So hopefully you said something like 25% of the scores were 55.31 or below. So something like that would be correct. So let's move on to the other types of problems that we can do with this. So let me scroll this down. All right, and there's really just two other types that we're going to talk about. And not surprisingly, they're going to be the different form of this. So question number 3, x bar is 60, s equals 7. What is the percentile score for x equals 50? So here, again, you can glance back up to the rule that we're going to use, but we're given the raw score. We're going to change that raw score to a z-score, and then that z-score to a percentile score. Okay? Notice also in both of these graphs we've identified the area that we're looking for, and we are shading that area and below. So up here, here, and below, because that's how a percentile score is interpreted, here and below. Okay, so let's look at number 3. Raw score, we're looking for the percentile for a raw score of 50. And so 50 minus 60 divided by 7 gives us a z of 1.43, or minus 1.43. So I go to my table. Again, I go to column C because I want what is at this z and beyond. So what is at this z and toward the tails. And what I find is that it is 7.64%. So that would be interpreted as 7.64% of the scores were at or below a 50, a raw score of 50. All right, the last type of problem, again, it's really similar to the one above, except it's on the right-hand side of the distribution. X bar equals 60, S equals 7. What is the percentile score for X equals 74.5? All right. So again, we know we are given the raw score. We're looking for the percentile score. We've got to change the raw score to a z-score, and then the z-score to a percentile score. So 74.5 minus 60 divided by 7 gives us a z-score of 2. So I've got something here. 2.0, I don't know, 2.07 or 2.02. I've got two different numbers there, so you'll have to figure out that math. Anyway, if you go to the z table, whichever one is correct, you would have found that there is 48% of the scores between the mean and the z. And why did I add it to 50%? Because I know 50% of the scores are over here. So 50 plus 48.08 says that a raw score of 74.5 is at the 98.08th percentile. So 98.08% of the scores are 74.5 or below. And again, below implies to the left of that line.